Okay, so we are starting derivatives of inverse trig functions. We've already done derivatives of trig functions. If you'll remember, the derivative of sine is cosine. The derivative of, pop quiz, tangent. Secant squared, nice. The derivative of secant. Secant x tangent x. The derivative of cosecant. Negative. Okay, good. How about the derivative of cotangent? Negative cosecant squared. I think that's all of them. Nice job. Derivative of cosine? Negative sine. Sweet. So this is not that. This is derivatives of inverse trig functions. So I want you, first of all, let's be looking at page 245 in your text. Page 245. It says the inverse trig functions were presented and reviewed in section 1.5. Another name for these is like arc sine or arc tangent. Okay. One thing that you need to be aware of, there's a common error on the outside of page 245. You see in the red? Common error. People think that if I have sine inverse of x, that is 1 over sine of x. Not true. That is not true at all. Okay? To divide by sine is not to have the inverse. 1 over sine x is actually what? Nope. Cosecant. Well, cosecant and sine inverse are not the same thing. Okay? So we need to be clear about that. If I have something like y equals the sine inverse of x, what that means is I'm talking about sine of y being x. Sine of y being x. When I look at inverse trig, I'm asking myself, at what angle? No, this is in your notes. I'll tell you what to put on your note card. To me, sine inverse asks the question, at what angle is something? At what angle is something? Okay, so I might have 1/2 is my answer. 1/2 is my answer.
I didn't know if he was on purpose or not, so I didn't want to interrupt you.
It comes back. I was just laughing.
Yeah, you did.
It's great. Technology is my favorite. I want to throw things. I want to just throw things today. One other thing that you need to know is while the sine function oscillates between -1 and 1 in the y-axis, so it goes like up, down, up, down, up, down. You're aware of that, right? The sine inverse function oscillates between -π/2 and +π/2. Here. Okay? That's rough sketch. The reason for that is it's backwards. Okay? Another way of writing sine of y, another way of writing sine inverse of x equals y is to say that sine of y equals x. And we just talked about this, okay? If I look at this and I haven't explicitly solved for y, did you see it? Am I right? It oscillates up and down. Is that right?
I just wanted to see it as a function.
Did you?
Yeah, it's just...
The second one?
Yeah, but it goes the other way around, sort of. So, like, as across the origin, it's that way.
Yeah, it's backwards. I told you that it was a rough sketch, but the idea is that it's bound here instead of here. Did you learn the little Deep and Wide song when you were little? Deep and wide. Anyways, this is that. It's just flipped. Okay. So sine of y, Lauren did. Lauren knows what I'm singing. Sine of y equals x. This is not explicitly solved for y. Can you see that? I've got a y in an argument here for sine. But we learned implicit differentiation. So it doesn't matter. We can take the derivative right here as it looks. So let's do that. Let's take the derivative of sine of y. What do you have? Cosine. So d dx of sine y and equals d dx of x. We're differentiating both sides. So when I take the derivative of sine of y in terms of x, the derivative of sine is going to be cosine y prime equal to 1. Right? Everybody is okay with that? So what that implies is that y prime is equal to 1 over cosine of y.
Which is inverse cosine.
Okay? Feels like it could be an inverse of cosine. They say that since our values are oscillating between negative pi over 2 and positive pi over 2, then in this case, cosine is going to be greater than 0. The reason for that is, what is cosine of negative pi over 2? Let's look at our unit circle here. If I'm at negative pi over 2 or positive pi over 2, and I'm doing cosine, all of that is to the right of the y-axis. So what that means is that cosine of y is greater than or equal to 0 in that area. Can you tell?
Yes.
Cosine's my x values. And so if I'm bound by negative pi over 2 to positive pi over 2, then I'm dealing with only right stuff. Okay, so in that case, cosine is positive. Cosine of x or cosine of y is going to be greater than or equal to 0. The next piece of information on your textbook is kind of out there. It says, let cosine of y equal 1 minus I would prefer that we looked at it like this. Let cosine squared y equal 1 minus sine squared y. So we're pulling from the identity. Let's put that identity. This will make a lot more sense if you know what we're referencing here. Let's cosine squared x plus sine squared x equals 1. That's the identity. So let's say instead I have cosine squared of y, and I can swing that x piece to the other side. Then now I can say cosine squared y is equal to 1 minus sine squared of y. Are you following? This is in the middle of page 245. Middle of page 245. Okay? So now I can take the square root of both sides, because what's on the bottom of this fraction is cosine y, not cosine squared y. So what's cosine y actually equal to? The square root of 1 minus sine squared of y.
Is that a note card thing?
Huh?
Is that a note card?
No,
equation?
not yet. Cosine of y is equal to 1 minus sine squared y. Based on the fact that I solved for cosine from my Pythagorean identity that says cosine squared x plus sine squared x equals 1. It's just that my variable in this case is the y instead of x.
Why do you keep the sine squared under the thing and not cosine?
Because I square rooted both sides. This was cosine squared y. When I square root a square,
Well,
I ended up with cosine y.
but why don't you do it to the sine?
I actually can't square root a difference individually.
Because 1 minus is also in there?
So this might as well, 1 minus is also in there. I can't square root the difference. Okay, so now here's what we know. Cosine y is equal to 1 minus sine squared y. You with me? I want you to go back up here in the notes that we've already taken and see that sine of y is equal to x. Are you with me? Sine of y is x. Well, I have down here sine squared of y. So how might I replace sine squared y with something related to x if I know that sine of y is x? Sine squared of y must be x squared. So sine squared of y must equal x squared. So I'm going to take out this sine squared y and replace with x squared. Okay. So cosine of y is actually equal to the square root of 1 minus x squared. All of that to say, the derivative in terms of x of sine inverse of x is equal to 1 over the square root of 1 minus x squared. 1 over cosine y, which is the square root of 1 minus x squared. Okay, this was a super long derivation process. I think it's necessary to do one time to get from sine inverse of x to its derivative. I think you got to go through that process once and understand what happened, and then from then on, don't do it, memorize it. Okay, so here are your derivatives of inverse trig functions. You got to have these in the bag. These are what you put on your note card. And when I wrote it on my note card, I did it vertically like this on the back side. And on the front, I put some identities that keep coming back up. And I called my note card trig stuff. So later on, whenever you have time, you might want to go write down some Pythagorean identities. We've seen a couple of double angle on there. For right now, I think you should write down what's on this slide right here. On the back, where you can reference them a lot. Can you use it on the test? I think we got to get good at it.
What is the next test? But then, this is like a brand new computer, so. Yes.
All right, so I just wrote a whole bunch of stuff on the board. And I know that you guys are not in position to go through a derivation again. So I wrote out the derivation, and I just want to walk you through it instead of having you try to understand it. I just want to explain it. Is that okay? So I started with y equals tangent inverse of x. I swung that tangent inverse and called it tangent of y is x, right? I didn't necessarily multiply by tangent on both sides. That's not tricky. But I understand that when y is the tangent inverse of x, then tangent of y is x. Are y'all following that? Then I used implicit differentiation to take the derivative of tangent of y equals x. What's the derivative of tangent? So I've got secant squared of y times y prime equals 1 from that x. Okay? So then I divided by secant squared y. So I've got 1 over secant squared y. 1 over secant squared of y is equal to y prime. Can y'all see that piece of information?
Yes.
Okay. Now, that triggers a Pythagorean thought. I've seen secant squared y before. How does that relate to tangent? Secant squared y is equal to 1 plus tangent squared of x, because the Pythagorean identity says 1 plus tangent squared x equals secant squared x. Can you see that? Okay. I don't have any information with regard to secant in my original equation. That's why we're going back to tangent. So we're swapping out secant squared y, and instead we're putting 1 plus tangent squared y. Can you see that? So now I have the derivative of tangent inverse is 1 over 1 plus tangent squared y. But wait, there's more substitution. Because tangent of y is x, tangent squared y is x squared. So I can swap tangent squared y, and I can call it x squared. Therefore, the derivative with respect to x of tangent inverse of x is 1 over 1 plus x squared. Okay? All right. So, let's talk about how... boo. I'm trying to get you some notes on these trig functions that will help you remember. I'm way less interested that you can derive it than you can come up with it when you need to. Okay? So, sine makes me think sinus. Sinus rhymes with minus. Y'all see that minus right there? Sinus rhymes with minus. So in the bottom of your derivative of sine inverse, there's a minus sign. Okay? The cofunctions are easy because the cofunctions all have that negative right here. That was bad. I don't want it to be purple. All of the cofunctions are negative derivatives. All of the cofunctions are negative derivatives. So cosine matches sine, except that it's negative. So if you can remember the sine one, you got the cosine one, it's just negative. Okay? I think the top three, these are the ones that we are going to use most often. I actually think they may be the only ones that show up on the AP test. The last thing I'm going to tell you is tangent has a plus sign in it right there. Plus.
Of course. Got it.
Plus. Tangent has a plus sign in there. So in my idea, I remember that tangent's got 1 plus. And also you lost the square root. The square root thing only happens on the sine one. It happens later on cosecant and secant. I think those are of far less importance. Okay?
Yep.
Are we good?
Yeah.
Are we decent at least? Sinus is minus. All right, so let's go ahead and try. This is example 6, and this is actually the last example that we could possibly work today. I did want to show you when I did the derivation of tangent. There's a picture that is in your textbook. Can you see this? So 1 over 1 plus x squared. This is the derivative of the function tangent inverse of x. Can you see that tangent inverse is just flipped tangent?
Yeah.
Right? And it has asymptotes along the top and along the bottom, just like tangent would vertical asymptotes. This one has horizontal asymptotes. Look at its derivative. This is the function y equals 1 plus x squared. Notice that tangent inverse is always increasing. So its derivative is always positive, always located above the x-axis. Notice also that when the tangent inverse function is the steepest, your derivative has a maximum. This is the peak. This is the highest it goes. Okay? Notice that when your tangent function is concave up like a cup, what's your derivative doing? Increasing. Increasing derivative. When tangent inverse is concave down like a frown, your derivative happens to be decreasing. Okay? Goodbye. Okay, so that brings us to example 6. It says differentiate each of the following functions. We got about 10 minutes to hope for goodness. So our first problem here is y equals 1 over sine inverse of x. And on the screen, I can move like this, and I can make it bigger for you sitting in class. On YouTube, you have to do that with your fingers because whatever I do to the slide doesn't record. Okay? So if you're wanting to zoom in on something, that's why I put it on YouTube, so you have that capability. So it says y equals 1 over sine inverse of x. What is that?
1 over 1.
Okay. What kind of function is that? It's a quotient. Therefore, we're going to use the quotient rule. Or.
I like the word.
Or. So we could either use the quotient rule here, or we could rewrite it. It's just 1 on top. It's just 1. So I could rewrite it as sine inverse of x to the negative 1 power. I can bring that dude up. Now I can do the power rule. It's going to be a power rule / chain rule thing, but it beats the dog out of a quotient rule.
It does. It really does.
Okay? So now y prime is going to be negative 1 times sine inverse of x to the negative 2 power. So that's the derivative of the outside function in terms of the inner function, sine inverse of x, times the derivative of sine inverse of x, which is 1 over square root 1 minus, sinus is minus. And now all that's left is the simplifying.
Hey, this is a not multiple choice.
So y equals negative. What's on top of this whole fraction? Is this guy going to stay on top?
So it'd be negative 1.
So he's going to the basement. All that's going to be on top is negative 1. Divided by, and we just got to throw that sine inverse of x squared to the bottom. And what else is on the bottom? The square root of 1 minus x squared. And put a bow around it or a box around it or whatever makes you happy. That's your answer. For part A, Brooks. That's part A. Jeez Louise. Okay, and we've got 5 minutes or 7 minutes, so we're going to hustle through part B. I love it when we hustle. I know y'all do. Y'all ready? Yep. Okay, so for part B, the equation is, it's f of x equals x times arctan or tangent inverse of square root x. And I'm out of room here. Sorry if y'all didn't get that all written down. Tangent inverse of square root x. Yay, YouTube. You're going to be able to go back and do that later. It's a product, he says. Yes, it's a product. This is not f prime. This is f.
Hey, why didn't you write arc?
I just put tangent inverse. I hate arc. Tangent inverse is faster to me. It's fine. Arctan and tangent inverse are the same thing. Mm-hmm. This is a product. It means tangent inverse. This is a product, okay? So for product rule, if I have f times g, I'm going to do f first times the derivative of the second plus the derivative of the first times the second, okay? So hustling, here we go.
X.
First, x times the derivative of the second. Hey, y'all are making me nervous back there. Sit down. I'm rushing. 1 over 1 plus x squared. Okay? Plus, pause, freeze, bad.
We didn't
do the inside. Okay? Catch this. This has got to be in red because we did badly. Watch this. We did 1 over 1 plus x squared, which was beautiful. Except it's not tangent inverse of x. It's tangent inverse of square root x. So now it's going to be 1 over 1 plus square root x squared times the derivative of the peanut. What's the peanut? The peanut is x squared. Square root x. So the derivative is 1 over 2 square root x. No, if you pack up, I'm going to break you.
There's too much going on.
You got 4 minutes. I'm going to publish that I'm going to break you on YouTube. This is great. 1 over 2 square root x. And the reason we had to multiply that by that is because there's an inner function on our tangent inverse. Can y'all see that?
Yep.
Okay? No. It's tangent. Okay. We don't have time for no. You either see it or you don't. Okay, carry on. Here we go. We've got plus the derivative of f. Do you see it though, really? No, I mean it.
Yeah. It's because it's square root x and not
It's not tangent inverse of x. It's tangent inverse of the square root of x. So we have to multiply by the derivative of that thing. She says, okay. What's f prime? 1. What's g?
Tangent inverse.
Tangent inverse of x. So quick.
Square root x.
I did that on purpose so I could mark it in red. All right. So now what's f prime? Let's clean it all up. F prime is going to be what's on top?
X.
X times 1 times 1. X over 2 times, this is going to be 2 square root x. I would write 2 square root x. I wouldn't do 2 times. Let's come right here and call it 2 square root x times 1 plus, what's the square root of x squared?
X.
So 1 plus x. Are y'all catching that simplification?
Yes.
Okay. Plus tangent inverse of square root x. I think this is as close, really close to the book. That was Taco Bell. The book doesn't like the radical in the denominator here.
Well, that's too bad. We're gonna
That's really
How do we get rid of that?
times by it.
Just y'all.
Multiply both the top and the bottom?
If my calculator can take it, I think the book can.
Yeah. No, they didn't. They didn't multiply by the top and bottom. They did x to the first. I'm going to put this on YouTube. X to the first divided by x to the 1/2 means I subtract my powers. 1 minus half puts me x to the 1/2 power in the top. This is our final answer.
I am low. You want
Final answer, square root x over 2 times 1 plus x plus tangent inverse of square root of x.